Hello, good morning to all of you. So we were discussing about the electron correlations methods, and last class we have discussed about the electron correlations and the correlation energy, and now we'll define the type of correlations, type of electron correlations, and some methods which incorporates the electron correlations uh, correction in the quantum chemistry calculation. So there are two types of electron correlations actually. One is dynamic correlations and other is non-dynamic or static correlation energy. So from the name you can guess that dynamic correlations will come due to the motion of the electrons, and non-static correlations will come due to the their positional dependency or something like their non-dynamic corrections. Okay, so the main error in the Hartree-Fock approximations actually comes due to ignoring the the correlated motions of each electron with every other. Okay, so this kind of electron correlation is called dynamical correlations because it refers the dynamical character, or it refers the correlated motions, means electrons are in motion, so they are correlated, and due to these correlations what type of correlations energy is coming, that is called dynamical correlation energy, and this type of correlation is called dynamical correlations. But for the static, you know that Hartree-Fock theory actually describes the closed shell molecules, so it only uses single Slater determinant, but electron can also exist not only the enclosed shell system, but it can also be some open shell type. So in this cases, electrons can have some correlations that is not actually dynamic, but that is coming from some static contributions. So this is called static correlations. So this type of problems arises when actually closed shell descriptions of the electronic structure is not sufficient. Okay, so this is because sometimes your highest energy orbitals like frontier orbitals like HOMO and LUMO are nearly equal energies, have some nearly equal. So like in this type of systems, Hartree-Fock theory cannot understand that which one will be filled up, either this one or this one, because this has to be closed. So either it will be filled up or it will be filled up. So Hartree-Fock theory actually cannot decide which of these should receive the electron pair and which should be empty, or actually which should be HOMO or which should be LUMO. Okay, so basically these systems are can be either singlet diradicals, which is also become unstable, and most probably these systems becomes actually in triplet diradical systems, and you know due to Hund's rule these systems become stabilized. Okay, so this type of systems, some static correlations are coming because this cannot be considered by this system, only this Slater determinant of these systems, or rather we have to consider this type of contributions also. So dynamical in both the correlations actually can be calculated by some post-Hartree-Fock method, that is more sometimes perturbation method, that is Molar placed perturbation method, or by some multi-determinant configuration interactions method that I will discuss a little bit. But these are, again I am saying that we are not discussing any mathematical details here. You just have to understand the theme of the calculations and how we are actually going more and more advanced calculations. Okay, so we are for example, in Hartree-Fock theory we did not consider the electron correlations. Now we are considering the electron correlations now, so we will get the better energy in these methods. Okay, and also multi-determinant method configuration interactions method, actually will discuss this, but this is that we assume that electrons can be electron can be in closed shell, but with the closed shell also there may be some electronic excitation takes place. So if we want to consider that, we have to consider the another determinant, like if we consider this one is a determinant for a closed shell species, so you have to consider also this determinant. So then there will become multi-determinant configuration interactions method. Okay, and these methods are actually used to incorporate or correct the electron correlations in the system. Okay, so let's discuss a little bit about Molar placed perturbation theory. Again, I am saying that all the mathematical discussions are not required because these are extremely tough mathematics, and we will just get the idea or theme of the calculation. So Molar placed perturbation theory is actually, it's a as it said, the perturbation. So you know that it based on perturbation theory. Okay, so there is a hierarchy of Molar placed energy levels, for example MP1, MP2, MP3, MP4, etc., which successively provide you more and more accurate correlations and more better energy. Okay, so MP1 is just the Hartree-Fock energy without any perturbation. MP2 is the called as Molar placed second order perturbation theory, is the first MP level that is beyond Hartree-Fock treatment, means that it first it will calculate the includes the electron correlation energy. So this MP2 energy is the Hartree-Fock energy plus a correction term of energy brought about from electron correlations. So you can write the simply that EMP2 is just E Hartree-Fock total plus E2. So E2 is the correction, second order corrections of the Molar placed perturbation theory for electron correlations. Okay, so the Hartree-Fock term actually includes internuclear repulsions. You know that we have ignored it in the Born-Oppenheimer approximation initially, but for the final energy we had to add this nuclear repulsion terms, energy terms. Okay, and the perturbation corrections, this E2 is entirely electronic term because here no nuclear thing is coming, and E2 is a sum of terms which of which models the promotion of pairs of electron, for that it said second order perturbation. Okay, so for MP3 it's a third order perturbation, will get far better energy. MP4 is the fourth order perturbation, which will consider the total 4 electron promotion and then calculates the energy. So in this way the energy will be calculated, but you the thing is that here, that when we are going to proceed to upper level like MP2 to MP3, MP4, our the calculation time will be very high. Okay, so actually we have found in many calculations that MP2 is the make and a compromise between accuracy and the cost of the computation. Okay, so Molar placed perturbation theory, one more thing you can from the name you know that this is perturbation treatment but not variational. So in this case there is no surety that you will get always the your energy higher than the total energy what is the you are found in variational treatment. Okay, so what happens actually, that is it wrong then? No, this is actually not wrong. That there seems two types of patterns may arise there. Like here I have shown in the figure that if your this dotted line is true energy, and there can be two types of calculations possible results may come. Like for say consider the system A, where when we are considering MP2, we have it's the higher than the true energy. So when we are going beyond the MP2 to MP3 to MP4 and higher method, we are observing that our energy is decreasing and it's going to almost it's going to merge with true energy. So when we will go to some infinite perturbation treatment, then we will get the exact true energy. Again, in case of system B, where the MP2 energy is found lower energy than the true energy, so when we will going to the higher methods, then what will happen? This energy will be rising and it will finally try to merge to the true energy. Okay, so in this way MP2 treatment or calculations can take place. So next type of correctional method for electron correlation is the configuration interactions. Okay, sorry, so a configuration interaction wave function is actually multiple determinant wave function. Means that in Hartree-Fock again we are telling you that in Hartree-Fock treatment we consider only a single Slater determinant, But in configuration interactions method, we will use multiple determinant wave function. So this multiple determinant actually constructed by starting with the Hartree-Fock wave function. So Hartree-Fock wave function is taken and making new determinants. So we first take Hartree-Fock determinants and we make new determinants by promoting electrons from the occupied to unoccupied orbitals. Okay. So configuration interaction calculations can be very accurate, but again the cost is extremely high. Okay, so configuration interaction calculations are classified by the number of excitations used to make each determinant. For example, MP2 in case of MP, Molar placid perturbation theory, we had the different degree of corrections. Here also we can take multiple determinant by promoting single electrons, by promoting double electrons, or promoting both single and double in this way. Okay. So if only one electron has been excited from the occupied to unoccupied, it is called configuration interaction single excitation level calculations. And single and double excitation calculation yield a ground state energy that has been corrected for correlations, that is called CIST. But triple excitation and quadruple excitation is also used to provide us very high accuracy results. So the configuration interaction calculations with all possible excitation, if you count, that is called full CI, and the full CI configuration with an infinitely large basis set can give you the exact quantum mechanical result. Okay. So here pictorially, if I want to show you that how we can excite the determinant. So this is just a Hartree-Fock determinant where all are closed shell. Here it's the two spin orbitals are showing as a parallel energy levels. So these are orbitals psi1, psi2. Okay. So if you want to excite the single excitation, then it can go up or it can go up. Which one will be? So you will have a singly excited determinant is this one. If you want to express this type of configuration in Slater determinant, you will get a singly excited determinant. Okay, but if you excite the pair of electrons from the occupied to unoccupied, you will get the doubly excited determinant. Okay, so on the basis of the considering the promotion of the electrons, the CI method can be classified. So this can be, you can say CISD only single excitation, but sorry, CIS single excitation, and this is CIST double excitation. And also we have to consider the all possible excitation, then we will get the full CI. Okay, and if you use the full CI calculations, mean they are all type of electron correlations will be incorporated. And if we use the most flexible, means the infinitely large basis set, then we will get the exact energy. Okay, but that is just theoretically possible. In practically in the calculations, we cannot use full CI even for a very small systems like water or like that. Okay, so thank you. We'll discuss few more electron correlation method in the next lecture, and then we'll go to the other methods. Okay, so thank you very much.